We encounter many figures and shapes, especially triangular shapes, in our day-to-day life. And at times, it is required to find the area of those triangular figures or structures. You have studied a formula for finding the area of a triangle in your previous classes. In this video, we will learn to find the area of a triangle using a different approach. Generally, we use the basic formula to find the area of a triangle, which is given by area is equal to half into base into height. One must have an idea about the base and the height. If any of the parameter is not given directly, area calculations become complex. That is, one should seek some means to find that parameter, then use it in the area equation. There arises the use of an alternative method. Here, the determinant comes into role. Yes, a method to find the area of a triangle using determinants. Let's discuss it in detail. Area of a triangle with its vertices x1, y1, x2, y2, and x3, y3 are given by area is equal to half into determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. Vertices written horizontally and then fill the remaining positions with 1. Now expand the determinant along the column 1 and we reach at this expression which is given by area is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. As we know, area is always a positive quantity. So take the absolute value of the determinant. Also, note when the area is given, one can use both positive and negative values of the determinant for calculation. Number 3, the area of a triangle formed by 3 collinear points is always 0. Let's see one question. If the area of a triangle is 35 square units with vertices 2, minus 6, 5, 4 and k 4, find the value of k. Let's see the solution. Here, given the area of a triangle is equal to 35 square units, now we have to use the area equation to find the value of k. Area is given by half into determinant of 2, minus 6, 1, 5, 4, 1, k 4, 1. Here we need to remember one point before proceeding. When the area is given, one can use both positive and negative values of the determinant for calculation. So we get plus or minus 35 is equal to half into determinant of 2 into 4 minus 4 plus 6 into 5 minus k plus 1 into 20 minus 4k, which is equal to plus or minus 70 is equal to 30 minus 6k plus 20 minus 4k. Again, on solving we get plus or minus 70 is equal to 50 minus 10k. Now when using the positive value we get 70 is equal to 50 minus 10k, which is equal to k, we get it as minus 2. Now when we use the negative value, we obtain minus 70 is equal to 50 minus 10k, and on solving we get k equal to 12. So the value of k can be 12 and minus 2. Next, we shall get into another application of determinant that is mainly concentrating on a system of linear equations in 2 or 3 variables, where we need to check the consistency of the system of linear equations. Before going to discuss that, one should know what is a consistent and inconsistent system. What is a consistent system? Consistent system is a system of equations where solution exists. And on the other hand, inconsistent system, when its solution does not exist, we say the system is inconsistent. When you get a system of linear equations like this, consider a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, A3x plus B3y plus C3z is equal to D3. You have to follow these steps. The very first step is to express the given set of equations in matrix form. How? First, we have to frame a matrix A where all the coefficients are placed. That is, A is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. So all the coefficients from that equation is framed and make it into a matrix. Now, what will be matrix X? X is equal to X, Y, Z, which contains all the variables in the equation. That is X, Y, and Z. And the matrix B, which contains all the constants, which is equal to D1, D2, D3. After this step, find the determinant of A. Either determinant not equal to 0 or determinant equal to 0. If determinant not equal to 0, we can say the inverse x's, and we have to solve the value of x, which is given by A inverse into B. Then we can conclude that system is consistent with unique solution. Now what happens if the determinant is equal to 0? If the determinant equal to 0, we have to find adjoint A into B. Again check if adjoint A into B is equal to 0 or not. If adjoint of A not equal to 0, we can say the system is inconsistent. That means solution does not exist. Else, if the adjoint A into B is equal to 0, system of equations may be either consistent or inconsistent, according as the system has either infinitely many solutions or no solution. Let's solve one problem for better understanding. So, the system of linear equations x plus 2y is equal to 2, 2x plus 3y equal to 3. Now, we know the given system of equations can be written in the form ax is equal to b, where a is equal to 1, 2, 2 and 3. What will be your x? X is equal to x and y, the variables in the equation. Now what will be b? B is equal to 2, 3, all the constants. Now first find the determinant. Determinant of A is equal to -1, which is not equal to 0. Therefore, inverse exists and the system has unique solutions, right? Which is given by x is equal to A inverse into B. Now find A inverse. What is A inverse? A inverse is given by adjoint A by determinant A. We get A inverse is equal to 1 by -1 into adjoint, that is 3 minus 2 minus 2, 1, which is equal to -3, 2, 2, -1. Now solve for x and y. xy is equal to -3, 2, 2, -1 into 2, 3. We get xy is equal to multiplication, perform multiplication of matrices. So we get -6 plus 6 in the first row and 4 plus -3 in the second row, which is calculated and we get it as 0, 1. Now compare both the matrices. We get x is equal to 0 and y is equal to 1. In this way, there are many applications of determinants which can be utilized in finding appropriate solutions to many problems in mathematics. Let's have a quick recap of what we have learned.
Manorama Horizon. Learning made simple.